Today I'm going to discuss transportation problem. First of all, I'm going to discuss how to find out the basic feasible solution. Actually, the transportation problem is solved in two steps. First, you have to find out the basic feasible solution, and after that, you have to optimize it. Now, I'm going to discuss to find out the basic feasible solution. There are basically three methods to find out the basic feasible solution. The first method is called northwest corner rule. The second one is called matrix minima method. Okay. And the last one, which is very popular, that is called Vogel's approximation method, VAM method. Now I'm going to discuss the northwest corner rule method first. Initially, I want to explain what is transportation problem. The transportation problem is noted through a matrix. Suppose these are the factories. The production is being done in 4 factories in different location of say this country A, B, C, D. The locations may be Mumbai, Delhi, Calcutta, and Sikkim. All these are the location of the factories, and these are the warehouses, godowns, or sales point. Suppose or the marketplace where you have to ship the product. Now here it is E, F, G. Now, what is this 10? 10 means if you want to shift one unit of the product which is being produced at a factory to the destination or warehouse to E, the per unit transportation cost is rupees 10. In this way, all transportation costs are noted here. Suppose from factory B, you are shifting the product to warehouses F, then per unit the shifting cost is rupees 2. In this way, say from factory D, you are shifting the product to the warehouse or marketplace at G, then the per unit transportation cost is rupees 8. So in this way, the transportation costs are noted to the matrix. Then what is the problem? Your final problem is from which factories, how much product you will shift to the warehouses or selling point, so that the demand for the warehouses or selling point is met, but the overall transportation cost will be minimum. This is the problem. So here, these are the availability. Availability means supply. You can say this factory is being produced say 15 units. It may be in thousand, maybe in millions, but say 15. B factory is producing 20 units, and C factory is producing 30 units. D product factory is producing 35 units. That means these are the availability. And requirement is noted here. Requirements. This is the supply or availability. You can say availability also. You can say availability, availability, and these are the requirements. E godown, E warehouses requirements 25 units, and F warehouses required 26 units, and G warehouses required 49 units. So first you have to find out the basic feasible solution. That is the starting solution. How you will do it, that I am going to discuss. First of all, you always check whether availability and requirements is same or not. Here, if you make total, then you will get 100 units, and if you make total this side also 100 units. That means the availability is equal to the requirements, and this is called a balanced transportation problem. But sometimes you will see this may not be same. Then what you have to do, that I will discuss later on. Okay. Now I am going to discuss northwest corner rule method. What is this? Northwest, east, west, north, and south. These are the direction. Northwest corner rule method, you will start allocation from this point. That means this point. You will start allocation this point. This is the rule. Northwest corner rule, because this side is east, this side is west, and this side is north, then this side is south. The northwest corner rule means you will start allocation from this corner. how will you allocate? And this is the availability and this is the requirement. So you put the minimum of these two values. Why? Because you cannot allocate more than minimum value. In this case, out of 25 and 15, which is minimum, this is minimum. That's why I'm writing 15. That means I'm allocating 15 units here. Why not 16? Why not 20? Because if you write 20 here, then is it possible 20? Because availability is 15. It is not possible to note 20. Because maximum you can allocate 15. But if you note, say, I want to put 10, then what will happen? That is also not possible, but not allowed, because over and above 10 units is also available. That's why you put the minimum of these two. Again, I will repeat in the next step, then you will understand why. If I allocate 15 units there, that means I will shift 15 units from factory A to the warehouse E. Then how much will be left for this factory? Because we have shifted 15 units from this factory to this warehouse, that means 0 units will be left. And how much will be required in future? 25 minus 50, that is 10. That's why I have written in this way. So in future, you cannot allocate in these boxes because the maximum availability already you have put here. Now suppose I am telling you, suppose here instead of 25, 18 is 14 is written here. Then how much will write here? Suppose instead of 25, 14 is written here. Then in that place you have to put here 14 because 14 is the minimum of out of these two. But in this case 25, that's why I have written 15. This is the minimum amount. Next step. We cannot move this side. We cannot load allocation here because we have already taken the maximum available amount units of the factory A. Then we have to move downwards because still we have to put 10 units. We have to move downwards. Now I have to allocate here. How will allocate? Again, every 10 units are required because already 15 have been sent. 10 units are required and availability is 20. Then how much you write here? The minimum of this and this. What is the minimum? 10 and 20? 10. That means this is the minimum amount. That means you will shift from factory B to warehouse E 10 units, and for that reason the remaining units for the factory B is 10. That's why I have written here 10. But here it is already set. Nothing is left required for warehouse E. The warehouse E required 25, 50 plus 10, 25 already you have taken. That's why you cannot move this place. This place is blocked because 25 already we have shifted. Then how will move? Then this side you can move, not diagonally, horizontally or vertically. So how much you will put here? How much you will allocate here? 10 and 26. What is the minimum quantity? Out of 10 and 26, the minimum is 10. That's why 10 will be written here. Okay, 10. So the balance requirement is 16 and this is saturated. That means factory B total units, available units have been shifted. You cannot move further here. This place is blocked. That's why horizontally is blocked. You have to move vertically. You have to move either horizontally or vertically. Now you have to put here. How much units you will put here? 16 is the requirement, still requirement, and availability is 30. What is the minimum? Out of 16 and 30, the minimum is 16. That's why I'm writing 16 here. The balance will be 0. That means the entire requirement have been fulfilled. And what is the balance amount for factory C? 30 minus 16. That means 14 units still available to factory, this factory. So this side is 0. The entire requirement has been fulfilled. 26. That's why you cannot move here. I have blocked this place. That means horizontally you can move here. That means the what will be the units you will put here? You will put here 49 and 14. You have to select the minimum one out of 14 and 49. The minimum is 14. You can put 14 here. You can maximum allocate 14. If you put 16, then in that case it is not possible as 14 units available. And you should not put the minimum also, but less than 14, because then again you have to move. The rule is you try to allocate as maximum as possible out of this availability and requirement. And the maximum possible units to allocate is 14 minimum. So if you put 14, that the remaining amount is 0, and this, that is 35, the balance unit is 35, and the last one is 35. This is also 35, that's why 35. The basic allocation will be this 35. That is 35, this is 0, and that is also 0, is allocated. As the total availability is equal to the total requirement, that's why it will be always balanced. Last time it will be met, same to same. That means nothing will be left. This is the initial solution, and you have to start from this place for optimize. I will discuss later on how we will solve or how we will optimize this transportation problem. This is the starting point of solution. That is, what is the basic solution, starting solution? That is, from factory A to destination or warehouses E, you should ship 15 units, and nothing here blank means you need not to shift any units to this, from this source to this destination. Nothing is written means 0. From B you are shifting to warehouses E 10 units, and from B factory 10 units are being shifted to F units. In this way, this is the basic solution you can find out. And what is the transportation cost? Initial transportation cost. Transportation cost for this initial solution, transportation cost, total cost will be is equal to 50 into 10 per unit. Shifting cost is rupees 10. 15 units are being shifted here. That's why 50 into 10 plus 10 into 5, 10 into 5 plus 10 into 2 plus 10 into 2 plus 16 into 7, 16 into 7 plus 14 into 4, 14 into 4 plus 35 into 8. This is the total cost for initial solution. While optimize it, optimize means in this case minimize the cost. Optimize means it may be maximized, it may be minimized, but for transportation cost problem, as we will try to minimize the cost, this will be the minimum cost. When you will apply the optimization technique, this cost will be reduced. And lastly, finally, it will be the least cost that I will show later on, and by applying MODI technique, modified distribution method, that will be discussed later on. And you will multiply, then you will get the amount as, you will get the amount as 15 plus 10, 150, 150 plus 50 plus 50 plus 20, 20 plus 16 into 7, 16 into 7 plus 40 into 4, that means 56, that means 35 into 8, 35 into 8, and total is 668, 668. This is the total transportation cost for the initial solution, basic solution. And after applying the MODI method, we will show this cost will be decreased step by step by step. Finally, the least cost will find out, and for that the allocation will be different. In our discussion in future, I will solve that by MODI technique, modified distribution method. That is the second step that we will show later on. But this is all about your northwest corner rule. This method I have discussed today is called northwest corner rule for finding the initial basic solution. This is northeast, northeast means northwest, NW method, northwest corner rule. This method is called northwest corner rule. This is east, west, north, south. Northwest means this point. We'll start from this point. That's why it is called northwest corner rule. Thank you.